Hello. How many people are in the crowd? Yeah. Is this everyone or is there more people? I think there's more people. Sorry? Oh, it's not coming. Oh, so everyone that is coming is already here? Okay. All right. Okay. We will continue with the topic of distance, speed, and height. So you all have done this in maths before, right? You have not done this in maths? Yeah. Yeah. Okay. Learn this in physics. Okay. Yeah, you learn this in physics too. All right. So let's look at the basic units. Okay, how do we change basic units from cm to meter and from meter to km and the opposite side? Okay. Okay. So from cm to meter, what is our change going to be? Yeah. Divide by 100. Okay. From m to km is divide by 1,000. Okay. All right. And then how about km to meter? Times 1,000. And then from meters to cm times 100. Okay. So this is your basic for distance. How about time? Time we have what? We have seconds, we have minutes, and we have hour. Okay. So how do we change seconds to minute? Divide by 60. Also divide by a 60. How about hours to minute? Times 60. And then minute to second times 60. Okay. So copy this down first. And then lastly, this one is your distance. This is your time. And then we got speed. Okay, speed is usually meters per second to kilometers per hour. Okay, meters per second, what do we times by? That's right. What do we divide by, not times? From meter to kilometer is divide by 1,000. And then from our second to hour is divide by 3,600. Okay, so you copy this one down first. Okay. So once that is done, let us try the first question. So a car travels a distance of 1,280 meters at an average speed of 64 kilometers per hour. Calculate the time it takes for the car to travel this distance. So what we want to calculate is, no, calculate the time it takes for the car to travel this distance. Okay, so distance divided by speed, yes. So your distance here is how much? 1,280. And then your speed is 64 kilometers per hour. We have to change our speed to from kilometers per hour to meters per second. Very good. So time equals to distance divided by speed. 64 times 3,600. Are you sure? Kilometers per hour to meters per second. So times weight, 1,000 over 1,000 over. This is only converting your kilometers to meters. You also have to convert your hours to second.
So also
Hours to second is how much?
times
3,600, yes. Okay, and then your top distance is going to be 128 0. So how much is this going to be? What is your final answer? 5.5? No, it's not 5.5. Yes, 72. Did everyone get 72? If you're getting the wrong answer, try to do the bottom calculation first, get your value, then only do the one. So you can round it up to 72. Okay. No, your answer is in?
so 72 seconds.
Yes, 72 seconds. All right, if everyone is done with that, let's see the next one. A car travels at 56 kilometers per hour. Find the time it takes to travel 300 meters. Give your answer in seconds, correct to the nearest second. Same thing as before. They want your answer in second, which is time, which equals to distance over your speed. So same thing as before. We got our distance is 300 meters. And then we got our speed is 56. We have to multiply by 1,000 to change your kilometer to meter, and then multiply by 3,600 to change your hours to second. So in the end, what answer do you get? Make sure you round it up to the nearest second. You get 19 by what? Are you sure?
19.
Yes, just 19. Round it up to the nearest second. No, nearest second. Nearest second would be 19. Okay. Once you have done question 1 and 2, try 3, 4, and 5. In 10 minutes, we'll discuss, okay? Any question you can ask. How do you calculate? You change your 18 minutes into a fraction. So it will be 18 over 60. So it will be 2 18 over 60, which you get a mixed fraction. So a mixed fraction, you can change it into a decimal. Yes. Zero 0.6 for which one? This one. No, it is not 0 0.6. It is 2 plus with 18 over 60. 18 over 60 is 0 point how much? 18 divided by 60 is 0 0.3. So it is 2.3. Mhm. So average speed, what is your formula? Total distance over total time. So make sure you add your total distance and then add your total time together. Then only you do the divide. Does everyone know how to find average speed? What is the formula for average speed? Yes, very good. Total distance over total time. Is everyone done? Last question. Okay. Okay, let's discuss that. Okay. All right, let's try the first one. So Fritz drives a distance of 381 kilometers in 2 hours and 18 minutes. He then drives 75 kilometers at a constant speed of 30 kilometers per hour. Calculate his average speed for the whole journey. So there's two parts here. The first part is this one. And then the second part is this one. Okay. So they want us to calculate his average speed. So what is the formula for average speed? Total distance over total time. Okay. So let's do the first one, the first part. So we got our distance, which is how much? 381. But do we have our time? 2 hours, 18 minutes. So can we use this? No, right? We have to convert it into decimals. Then only we can use it. Okay, so it is going to be 2 plus. How do we convert 18 minutes into decimals? 18 divided by 60. So 2 plus 18 divided by 60 is how much? 2 plus 0.3, which is 2.3. Okay, so far okay? So we got our distance and we got our time for the first part. Now the second part. We got our distance here, which is 75. But do we have our time? We don't. We got speed. So how do we change the speed into time? It would be 75 divided by 30. Yes. We get 2.5. Okay. So now, for both our parts, we got our distance and we got our time. So now let's put it in the formula. Total distance, which is going to be 381 plus weight, 75. And then our total time is 2.3 plus 2.5. And then what is your final answer? It's 456. Right. 456 over 4.8, which is 90. Are you sure 94? 95. 95. What's the unit? Kilometers per? Yes, kilometers per hour. Yes. Oh, what is the way that you did? Okay. Okay. Okay, and then what's next? Oh, okay. Yeah, it's the same way. Yes, it's correct. Okay, let's move on to the next question. A train takes 65 minutes to travel 52 kilometers. Calculate the average speed of the train in kilometers per hour. So we already have our distance here, which is 52. And then we got our time in minutes. We want it in hour. Okay, so speed equals to distance over time. So let's calculate our time. 65 minutes. How do we convert it into hour? Yes, we can do 1 hour 5 minutes. Okay, yeah, we can do 1 hour and 5 minutes. And then we convert this into a fraction, which is going to be, it's going to be 1 plus 5 over 60, right? Is it correct? Because 5 minutes, you convert it to an hour is divided by 60. So it's 1 plus 5 over 60, which is 5 over 60 is 0.083. Okay. 1.0 is okay. Yes, 52 divided by 1.083. You get 48. Everyone got the same? Okay, let's do the last one. A train of length 120 meters is traveling at 144 kilometers per hour. It passes under a bridge of width 20 meters. Find the time taken for the whole train to pass under the bridge. Give your answer in seconds. So we want to find time. So what is the formula we're going to use? Distance over speed. Yes. So we got our speed here, which is how much? 144. 1,000. Correct. Times with 1,000 over 3,600. Are you sure it's 120 above? 140. Why is it 140? Because of the bridge. Okay. So let's say we have a bridge of 20 and then we got a train coming here. Okay, this is your train. This is your bridge. So the bridge remains at 20 meters. Your train is 120 meters. So if you want to fully pass, the whole train to fully pass under the bridge, it must be, the train must be here, and then the bridge must be here. That is fully passed. Okay? If you have something like this, when you have the bridge here, and when you have the train here, is it fully passed? No, right? Because your train is still passing the bridge. Okay? So we cannot consider this as fully passed. We only can consider this here as fully passed. So that means we must add 20 to 120. Then only we get the full distance. Okay? All right. So that will be 120 plus 20. But is this the correct unit? It's in meter. Okay, so it's correct. So we have 140 divided by how much? 40. Which is? 4.5, but round it up. You leave it as 3.5 seconds. You don't have to round it up. Because here they never ask you to round it up. So just leave it at 3.5. Okay. All right, the next three questions, try to do also. Then after we discuss. Sorry? How to do which one? 7. A person in a car is traveling at 108 kilometers per hour, takes 1 second to go past a building on the side of the road. Calculate the length of the building in meters. So you got this, you got speed and you got time. So how do you calculate? Sorry? One. You want to calculate the length of the building, right? Yeah. So first, you have to convert your speed into. It is in kilometers per hour. You have to convert it to, because it is in, yes, meters per second. You do that first. 30. Okay. So what is the formula to calculate distance? Speed times time. Okay. So speed is 30 and time is One. Yes. 30 meters. Okay. Mm. Yes, yeah. Okay, let's discuss number 6. So the length of the train is 210 meters. It passes through a station of length 340 meters at a speed of 180 kilometers per hour. Calculate the number of seconds the train takes to pass completely through the station. Okay, so we need to find our time. So what is our formula going to be? It's going to be distance over our speed, right? And then 210 add with 340 divided by 180. You have to convert this to meters per second. So times 1,000 divided by 3,600. Okay, and then what is your final answer? Your top is going to be 45550. Your bottom is going to be 50. Okay, 11 what? Seconds. Okay, did everyone get 11 seconds? Okay. Okay. And next one. A person in a car traveling at 108 kilometers per hour takes 1 second to go past a building on the side of the road. So they want you to calculate the length, which is distance. Distance is speed times time.
So first we convert 1 to
2. Convert your speed into meters per second, which is times 1,000 divided by 3,600, which is going to give you 30.
and since it's speed times time,
Mhm.
it's 30 times 1,
30 times 1.
which gives us 30 meters.
Yes. Everyone get 30 meters? Okay. Last one. A train travels for m minutes at a speed of x meter per second. Find the distance traveled in kilometers in terms of meter, as in terms of m and x. Give your answer in its simplest form. How to do this?
Yeah, m over 1,000, then we times x.
M over 1,000.
Now since m is minutes and we need to change minutes to kilometers, we divide by 1,000.
You want to change minutes to kilometers.
Yeah, so find the distance traveled in kilometers.
How you change minute to kilometers?
Oh, wait, one
You have to change minute to seconds, right? So m must times with m must times with minutes. 1 minute is how many seconds?
mx.
No, 1 minute how many seconds?
1 minute.
60 seconds. So this you convert it into seconds. Okay. So this one right here is your second. So, and then what's next? We want to find our distance, right? So distance is speed times time. Okay. So we got our time here ready, which is m times 60. What is our speed?
X.
X. So x times with m times 60. Okay. But then he said he traveled here you want it to be in kilometers. So you must divide by how much? 1,000, yes. Okay. So this is going to be your final answer. So you can just open the bracket, which you will get xm times
60 x.
sorry,
That's m over 1,000.
60 xm over 1,000. Okay. All right, then let's look at the next chapter. It's going to be your graphs. So you have your two graphs here, distance time graph and speed time graph. Okay. So the only thing here that is changing is the y-axis. So for distance time graph, it's going to be distance. The speed time graph is going to be your velocity in meters per second. So what does the gradient tell you in a distance time graph? Gradient tells you your speed. And for a velocity time graph or a speed time graph, it tells you your acceleration. Why does distance time graph tell you your speed for your gradient? Any idea?
The speed goes up faster.
Because
The longer
in order
is-
to calculate your gradient, you will need both your distance and your time. Okay, you need to calculate the area. Am I right? So how do you calculate the area?
You find a triangle, which is that
Okay.
one.
Okay.
Find the area of the triangle.
Yes.
Right. That one is going to be
So you can just write this down, that speed equals to distance over time. And then your gradient here equals to
area under the graph.
your kilometer divided by your time in hour. Okay.
Which in this case is 2 hours, right?
Yes, in this case here is 2 hours. And then your distance is 30. And then the next one is going to be your acceleration, which is going to be in velocity or your speed divided by time. And then you can find the distance traveled, okay, as the area under the curve. Okay. So how do you find area under the curve? You're going to split your triangles here. So you have a triangle, you have a rectangle, and you have another triangle up here. Then you can split to another triangle down here. Okay. So you just make as many shades as you want, and then you find the area under the curve, and that will give you your area under the curve will give you your total distance travel. Okay. So distance travel equals to area under curve. Okay. So that is what you need to know about this. Yes. Yeah, sure. Okay. So let's try to do the first exercise. They want you to calculate the total distance travel. So total distance travel is area under the curve. So you have 3 sections here. 1, 2, 3. So let's do one by one. So for number 1, how are we going to find the area under the curve?
1/2 times 75.
It's 1/2 times 20 times 12.5. Okay, and then your second one is how much?
Second one is 200
200 times
times
12.5. And then your third one is 1/2 times 60,
also for
12.5. So all your answers that you get for 1, 2, and 3, you add them up, and what is your final answer?
3,000.
3,000. Very good. What's your units?
Yes.
Yes.
Using of here again. Whole boundary.
Everyone got 3,000?
Yeah.
Okay. So I want you guys to try 2 and 3. Okay, it's the same concept. You have to find the total distance traveled. Yes, 2 and 3. All different. Car travels 20 meters per second for 15 seconds before it comes to a rest by decelerating to 5 meters per second. Find the total distance traveled. So it travels 50 seconds at a constant speed, at 20 meters speed.
This is your
20 divided by 2. Okay, so your speed here is 20, right? Okay, so it's decelerating at 2.5. So you're gonna find your time. Okay, so it's gonna be 20, which is your speed divided by your acceleration, you get your time.
20 divided by
Yes. Can we discuss? Okay. All right. So the diagram shows the speed time graph for 90 seconds of a journey. Calculate the total distance traveled during the 90 seconds. Okay. So total distance is area under the curve, right? So it's everything here. Okay. So how are we going to do this? Is we are going to do them section by section. Okay. So we split it into two sections. We got first part, and then we got the second part. All right. So let's do the first part first. What shape is this? A trapezium. What's the formula for a trapezium? Half times A plus B times height. Yes. Okay.
And we just do like triangle plus.
You can also, you can, I mean, in that case, you're going to have to do 1, 2, 3. You can do that also, but this case, you're only doing two parts. So let's try with the two parts first. So what is our A and B? Our shorter distance and our longer distance. So it's going to be 30, 60, and 90. And then what is our height? Are you sure? It's 12 minus 6, which is 6. 12 minus 6 is 6. Okay. And then what's your final answer for this part? 450. Okay. And then the next one, the triangle, the rectangle at the bottom. 90 times 6, which is 450. Okay. 540. Okay. So if you plus them both together, yes, you get 990. Everyone got 990? Okay. If you want to do the triangle one, you will have to do 1/2 times width. What is your base and height? 30 and? No. 12 minus 6 is? So it's 30 times 6 times 1/2. Okay. And then your rectangle here is 6 times this line is 60, right? 90 minus 30 is 60. So 6 times 60. Okay. So for 30 times 6 is how much? 180, right? 180 divided by 2 is 90. 90, and then you have this part here, 6 times 60 is 360. 90 plus 360 is?
90.
Yes. 450. So it's the same thing what you're getting here. Okay. So you can do either way. You want to split into 3 shapes, or you can do it in 2 shapes. Depends on you. Let's move to the next part. So a car travels at 20 meters per second for 15 seconds before it comes to a rest by decelerating at 2.5 meters per second. Find the total distance traveled. So we got the speed here, 20. We got our first this time here, which is 15, but we don't have our second time. How are we going to find that? We know that it's decelerating at 2.5 meters per second. We know our speed is 20 meters per second. So what can we do here to get our time? Any idea? Sorry? How do we find missing time? Sorry? Speed times time. What is that? Oh, you mean the final answer?
Yeah.
Okay. But how do you get the missing time though? Oh, okay. You're doing that way. Okay. All right. But that's really long though. So the easiest way how you can do this is you just use the speed that you have divided by your deceleration here. So it's going to be 20 divided by 2.5. And then you'll get this distance, this line here, which is 8. Okay, so in order to get this final time, it is 15 plus 8, which is 23. Yes. Yeah. But remember the answer that you're getting here when you divide is this time from 15 to 23. Okay, so make sure you add 15 to 8, and then you get 23. Okay, now you have all the information that you need. Same thing as before. We can do the trapezium calculation. 1 over 2, A plus B, H, 1 over 2, 23 plus 15. What's your height? 20. And then what's your final answer? 380. Everyone got the same? Sorry? Oh, 23 plus 15, sorry. Yeah. So let me show you the calculation for the speed here. So you have meter over second divided by meter over second square. So when you divide this, you would have the times. You'll change this into times, and then you're going to flip your seconds square up and then your meter down. And then when you do the calculation, you will get finally the seconds. Okay, so that is what you want to find here. So this is your speed divided by acceleration. You get your time. Okay. Any questions? If no question, then time is up, right? Yeah. Okay. And that's all for today.
Aaron, done with the first